Hi, Chris. Thank you for sending me the updated spreadsheet. I've been thinking a little more about your project and how we want to analyze the data. And I still think doing an analysis of variance for the self-confidence survey results is a good idea. But I realized after thinking a little more that the data needed to be arranged in a certain way in order to do this. So I thought I would show you how we would rearrange the data and then how we would perform the analysis of variance tests. So I looked at the table and I decided to just focus on the I can identify the kind of graph required based on the data question. And then I looked at each of the responses and your coding where you assigned a 4 to very confident, and then a 3 to somewhat, and so on. And then I just took that data and rearranged it. So here's what it looked like. I put it in a tab called column data. So for October, we had one person who said very confident, 1, 2, 3, 4, 5 people said somewhat, and then 1, 2, 3 people said not very, and then we had one person who said not at all. So I hope that makes sense. And then did the same thing for the February results. So I went over and said, okay, so 5 people said very confident, so that I needed to put in 5 4s, and then 4 people said somewhat, and then we didn't have anyone else. So this is how the data need to be set up in order to do the analysis of variance test. So I thought I would just show you that one time. So I have the data. We added the data analysis tool pack for you in Excel. Oh, another thing I had to do, which was tripping me up for a minute, was that, and I remember this from before, that the data needed to be numeric. So let's see if I can demonstrate this. I hope so. If I right click on any cell in here and say format cells, and it's categorized, the data are categorized as general. So in order to do the ANOVA, I had to highlight all of this. I had to right click, format cells, and say number, and I really didn't need to have 2 decimal places, so I can get rid of that. So they just have to be numbers in order to do the analysis. So I'll say okay. Now, just to be thorough, I just can't look at the 2 things being different, so I have to do this. So no decimal places. Okay, so we're ready to do the analysis of variance. So the analysis of variance, like I mentioned, looks at the 3 different groups, October, February, and May. It looks at the variability in the responses, so the differences, between the 1 and the 2, 3, and 4, how those things vary within the group. And then it kind of compares that variation to the variation among the 3 groups. So I don't think I was very articulate when I said that before. So we can already see differences. If we just look at the data, we see that we're getting more 4s, a lot more 4s in February, and then a little bit more in May. So I know I'm holding you in suspense. So I want to do analysis of variance. So I click on data analysis, and I want ANOVA with a single factor, ANOVA, single factor. The single factor is the time in which you did the study. So say okay. And then I need to do my input range. So I'm going to go to the spreadsheet and just highlight those 3 columns. I need to say the data are grouped by columns. I highlighted the names of the months that you did the study, so I click on labels in first row, and then I select new worksheet, apply. That's going to give me a new tab, and so I say okay. Okay, good, it worked. So what I get are the means, the averages for each month, the variation, and then this guy is a really important thing here. This is the p-value, this is the probability. So if this thing is really small, then that's good news. Let's see if I can fill it. Yeah, okay. So if this is small, usually smaller than 0.05, then that suggests that there is a significant difference between the groups. So the way it's interpreted is if there really were no difference between the groups, there would be looks like a 0.23 percent chance of observing a difference as large as what you saw or larger. So then we could conclude that for that particular question that we were asking about, that question of I can identify the kind of graph required based on the data, then you would be able to say in your report that because of this p-value less than 5%, you can say that the differences in student self-confidence for this question are statistically significant. Okay, I'll talk to you a little bit more about this because in using this test, we're kind of making an assumption. The sample sizes are really small, so it's usually we're not supposed to use this method when the samples are small, and there is another way that we can do this with a kind of a fancier statistical program. So if you want to go that route, I'd be happy to do that with you. So let me know. All right, I guess I'm going back to grading. This has been a really nice break. Thank you.